Hello friends, I am Snehal and I am teaching you physics. In this lecture, we will study about multiplication of vector quantities. So let us start. There are two types of multiplications of vector quantities, scalar product and the other one is vector product. Scalar product is when we have two vectors and the resultant of the multiplication is a scalar. For an example, we have work which is a scalar quantity and it is multiplication of force to displacement, where force is a vector and displacement is also a vector. So suppose we have this block here and somebody is pulling this block in this direction. Let's call it F bar. F bar is the force, and suppose the block gets displaced along this x-axis and S bar is the displacement. Now I can resolve this force in two components. So suppose this angle is theta. This is x component, fx bar, which is, I can say, fx into I cap, and on this y-axis this is the y component, fy bar, which is fy into j cap. Now this much length is f and this much length is fx, so we can find cos of theta, which will be equal to this side divided by this side of triangle, so fx divided by f. So we know how to resolve vectors, so fx will be equal to f cos theta. Now since the displacement is along this x component of force only, I can say that only the x component of force is doing some work and no work is done by this y component because there is no displacement along this y-axis. So the work done can be written as fx multiplied by s only, because force acting in direction of displacement is only fx. And what is fx? So it is f times cosine of theta. So it is f cosine theta into s. F is magnitude of force, s is magnitude of the displacement. So I can write this as w equals to f into s into cosine theta. So this is the work done, and we got here the rule to find scalar product of two vectors. So rule is like this: magnitude of first vector into magnitude of second vector multiplied by the cosine of angle between two vectors. So suppose we have a bar and b bar, then the scalar product will represent like this: a bar dot b bar is representation for scalar product, and it is equal to magnitude of a bar into magnitude of b bar multiplied by the cosine of the angle between two vectors. And we write these magnitudes simply like this: a into b, magnitudes of a and b into cosine theta. Okay, so this is the scalar product of two vectors. Now suppose we have these two vectors, a bar equals to ax into I cap plus ay into j cap plus az times k cap, and b bar equals to bx into I cap plus by into j cap plus bz times k cap. So we have to find the scalar product of these two vectors given by these components. So what we'll do is we'll find the scalar product of these unit vectors first. Then finding scalar product of these vectors will become easy. So let's find scalar product of unit vectors. So see, what will be I cap dot I cap? These are unit vectors along x-axis. So it will be magnitude of I, which is 1, magnitude of this I, which is 1, multiplied by cosine of the angle between two. So they are both along x-axis. So the angle is 0. So cosine of 0 is 1. This is equal to 1. Therefore, I can write I cap dot I cap equals to j cap dot j cap equals to k cap dot k cap equals to 1. Because these are unit vectors along y and z axis. Then what about this I cap dot j cap? So it will be equal to magnitude of first vector multiplied by magnitude of second vector multiplied by cosine of the angle between two. So angle is 90 degree and cos of 90 is 0. So this thing is 0. So similarly, I can write I dot j equals to j dot k equals to k dot I, and it is 0. Now we represent the scalar product by this dot, so it is also called as dot product. Okay, now we know the scalar product of these unit vectors. So let us find scalar product of a bar and b bar. So a bar dot b bar is equal to this ax into I cap plus ay into j cap plus az into k cap multiplied by bx into I cap plus by into j cap plus by into j cap plus bz times k cap. Okay, then now let's multiply it out. So we have this ax into I cap multiplied by that bx into I cap plus by into j cap plus bz into k cap. So it will be ax bx multiplied by I dot I, and we found what is I dot I, it is equal to 1. Then therefore I can write this as ax bx into I dot I, which is 1. Then ax by times I dot j, and we know I dot j is equal to 0. So this second term will give me 0. And ax bz, then I dot k is also 0. So we have this only term when we multiply ax into I cap with this b bar. Similarly, the only term which will survive when we will multiply ay into j cap to this b bar will be this ay into by plus, then we have az into bz and az into k cap multiplied by this I cap and j cap, it will give 0. So we have az bz. So we got this. Okay, so this is scalar product of a bar and b bar. Now let's see some properties of scalar product. And properties are a bar dot b bar is equal to b bar dot a bar, and it is obvious, as you can see, what is a bar dot b bar? It is a magnitude of A into magnitude of B multiplied by cosine of the angle between two vectors. So B bar dot A bar will be magnitude of B into magnitude of A into cosine of the angle between two vectors. And since magnitudes are numbers, so whether I multiplied A with B or B with A, it's the same thing. So this is obvious. So this is called as commutative property. Second one is distributive property, and this property says that the scalar product is distributive with respect to addition. So suppose we have A bar, we take its scalar product with B bar plus C bar. So what will be resultant of this? It is just as taking scalar product of A bar to this B bar plus scalar product of A bar to C bar. So it is equal to A bar dot B bar plus A bar dot C bar. So this is distributive property of scalar product. Then let's see an application of scalar product. Obviously, the scalar product will appear in too many examples in physics. So we'll see another application or use of scalar product. Finding out angle between vectors. So suppose you are given two vectors, let's say A bar and B bar, and we have to find angle between the vectors. So how can we use scalar product for that? So let us see. We know that A bar dot B bar is equal to this A, the magnitude of A into magnitude of B into cosine of the angle between two vectors. So what will be cosine of theta? So it is just A bar dot B bar divided by these magnitudes, multiplication of magnitudes. It is A bar dot B bar divided by magnitude of A multiplied by magnitude of B. So this formula is worth memorizing, or actually this formula and this formula is same, but using this we can find this theta. If we take cos on the other side and we take cos inverse or cosine inverse of this right hand side, we'll get the angle theta between the two vectors. Now we know that A bar dot B bar, we'll have to substitute it. It is equal to this. So where A bar dot B bar is equal to AX BX plus AY BY plus AZ BZ, and we also know these magnitudes because we know resolution. So magnitude of A is square root of AX square plus AY square plus AZ square, and magnitude of B is square root of BX square plus BY square plus BZ square. Okay, so we'll substitute these values, and then this is how we find angle between two vectors. Okay, now let's see vector product. So this time we have two vectors and we multiply them, and the resultant is also a vector quantity. So let me define it for you, then we will see examples. So vector product. So suppose we have two vectors A bar and B bar, and we take their vector product, the resultant is C. Now see, this vector product is represented by this cross, so it is also called as cross product. Just like the scalar product is called as dot product because it is represented by a dot. Now the magnitude of this resultant C bar is given by magnitude of A into magnitude of B multiplied by sine of the angle between two vectors. So suppose angle is theta, so magnitude of C bar is magnitude of A into magnitude of B multiplied by sine of the angle between two vectors. We know that for scalar product, if A bar dot B bar is C, then C is equal to AB cos theta. In this case, it is AB sin theta. That's the difference. And there is another difference, that this was scalar, just a number. In this case, it's a vector, so it has got this magnitude as well as direction. So how to find direction of this resultant? For that, we have a rule called as right-handed screw rule. So what does it say is that we have to rotate right-handed screw from first vector to second vector through smallest possible angle. Then the direction in which the screw will advance, it is the direction of resultant. So suppose we have our two vectors A bar and B bar lying in xy plane and angle between them be theta. Then if I rotate the right-handed screw like this, so this is direction of A bar, this is direction of B bar, I will rotate the right-handed screw from A bar towards B bar, so it will advance in this vertical direction. It means that the direction of resultant will be along this vertical axis or Z axis. So this is C bar. Notice that it is perpendicular to A bar as well as B bar. So this is right-handed screw rule. Or there is another rule called as right hand rule. So what we have to do is that we have to take our right hand, keep it in direction of first vector, then curl our fingers in direction of second vector through smallest possible angle and stretch our thumb. Okay, so keep the right hand in direction of first vector, which was this direction, curl fingers towards the second vector, which was this direction, and stretch the thumb. So stretched thumb will give direction of resultant. Okay, so it is right hand rule. Then what is an example of this? Suppose we have this parallelogram let's call it PQRS, and these two adjacent sides of this parallelogram are represented by these vectors A bar and B bar, and I am interested in finding out area of the parallelogram. So we know area of parallelogram is base multiplied by height. So area of this parallelogram or quadrilateral PQRS is equal to length of base multiplied by length of height. Okay, so the length of base, it should be clear that it is magnitude of this vector A bar. What about height? So let's draw a perpendicular here, and suppose it meets at this point T. Now this ST is the height of this parallelogram, we have to find ST. So angle between A bar and B bar is theta. So let's find ST. In this triangle, sine theta is equal to ST divided by PS. So it is ST divided by PS. So sine theta is ST divided by magnitude of B bar is length PS. So this is magnitude of B bar. Now I can take B bar on other side. So I get ST, which is height, and it is magnitude of B into sine theta. Now we can substitute it here. So length of base is magnitude of A and length of height is this magnitude of B multiplied by sine theta. So area of this quadrilateral PQRS is equal to magnitude of A into magnitude of B multiplied by sine of the angle between two vectors. Okay, so this is an application, or this is the use. So suppose two adjacent sides of a parallelogram are represented by two vectors, then the area of parallelogram will be the magnitude of vector product of those two vectors. Now suppose A bar and B bar, the two vectors, are given in their component forms, and C bar equals to A bar cross B bar. So we have to find C bar in the component form. So let's do that. So suppose A bar equals to AX into I cap plus AY times J cap plus AZ times K cap, and B bar equals to BX into I plus BY into J plus BZ times K, and C bar equals to A bar cross B bar. Now we have to find expression for the C bar, that is we have to multiply out A bar and B bar. So before that, let's find the multiplication or vector product of unit vectors so that this multiplication will become easy. Okay, so what will be I cross I? These are unit vector along x-axis. So let's find magnitude of this. So it is magnitude of first vector into magnitude of second vector. So because they are unit vectors, it is 1 into sine of the angle between the vectors, and because they are in same direction, angle is 0, and we know that sine 0 is 0, so this is 0. Okay, similarly J cross J and K cross K will be 0, so I have I cross I equals to J cross J equals to K cross K, and all of that is 0. Then what is I cross J? So we know I is unit vector along x-axis, so this is I cap, and J is unit vector along the y-axis, so this is J cap. What will be I cross J? So let's use right hand thumb rule or right hand rule. So we keep our right hand in direction of this I cap, curl our fingers towards the J cap through the smallest angle. This is the smallest angle, this is large angle. So we curl our fingers and stretch the thumb. So stretched thumb gives the direction of Z axis. It is perpendicular to X as well as Y. So this is positive Z axis. And what will be the magnitude? So let's find magnitude of I cross J. It is equal to 1 into 1 the sine of the angle between two, which is 90 degrees, and sine 90 is 1, so this magnitude of I cross j is 1. And we just found that direction is along this positive z axis, is perpendicular to x and y. So a vector having this much magnitude or unit magnitude in positive z axis is k cap, and that's why I cross j is k cap. Okay, what about j cross I? What will be j cross I? It's clear that magnitude will be same, 1 into sine of 90 degrees. But what will be the direction? So for that we keep a right hand in direction of first vector, in direction of j, and curl our fingers. So surely I cannot curl my fingers like this. Okay, even if you are more delicate than me, it's not natural to do so. So what we have to do is keep our right hand like this. So in direction of this first vector j cap, then curl fingers towards the second vector I cap and stretch the thumb. Now you can see in previous case it was in this direction outside the plane of board or positive z axis. Now it is inside the plane of board, into the plane of board, or negative z axis. So this is going to be minus k cap. It is negative z axis. Okay, so I cross j is not equal to j cross I. Okay, what does it mean is that a cross b is not equal to b cross a. A cross b equals to minus of b cross a. So vector product does not obey commutative rule. Okay, so similarly, just like I cross j is k, I cross j is equal to k, then j cross k will give me I, and k cross I will give me j. You can check that by drawing this right-handed coordinate system like I, j, k. These are unit vectors along x, y, z axis. So I cross j gives k is in this direction, then j cross k gives I, and then k cross I gives j. Okay, and if we take it in reverse order, then answer will be negative. So how to memorize this? To memorize it, we draw this circle, then we take these 3 points, write I, j, k, and then we draw arrows like this in clockwise direction, these 3 arrows. Now the way to memorize this is that multiply I with j. So if you are going in direction of arrow, the result will be positive k. If you are going in opposite direction, if you are taking j cross I, then the result will be negative j. Similarly, j cross k, in direction of arrow, j cross k, I, answer is I. K cross j will be minus of I. Okay, so we have to memorize only this much. So let me just draw it here. So this is my I, j, and k, and these are the arrows. Now let's do the multiplication. So a cross b equals to ax into I cap plus ay into j cap plus az times k cap. I think we'll rewrite it here. A cross b equals to ax into I cap plus ay times j cap plus az times k cap. multiplied by bx times I plus by times j plus bz times k cap. Okay. Now let's do the multiplication, and for that let's multiply ax into I cap with this. So we know that I cross I will give 0, so better we multiply ax with by, and I cross j will have then ax into bz, so plus ax bz into I cross k. Then when we multiply with this ay into j cap to b bar, j cross j will be 0, so what remains is ay bx, so plus ay bx j cross I plus ay bz times j cross k. Then multiplication with this plus az bx, it is k cross I plus az by times k cross j. Okay. Now let's substitute for I cross j, I cross k, the vector product of unit vectors. So what is I cross j? I cross j is k, so it is ax by times k cap ax bz times this I cross k, so I cross k opposite direction, so minus j cap plus ay bx j cross I minus, because we are going in opposite directions, so it is minus of k cap plus ay bz j cross k same direction, so plus I plus ay bz times I cap, then az bx, so az bx to k cross I same direction, so that's why j cap plus az by k cross j, so k cross j opposite direction, so minus I, so az by into minus it was k cross j, so minus I. Okay, now let's take the terms common from here. So c bar or a cross b is equal to, let's take terms containing I cap, so I cap multiplied by ay bz minus az by, then I will take minus j. Okay, why I will explain you. Minus j cap ax bz from here minus this az bx, it is positive but I have taken this negative sign common, so ax bz, this becomes negative, minus az bx plus k cap times ax by minus ay bx. Okay, and this is vector product in component form, or these are components of the C bar. So we have to memorize this, and for a normal person it will be quite difficult, so we use a trick. Let me tell you. we write it, or C bar is A cross B. So we write A cross B like this in this determinant. First row we write IJK. Then in second row we write AX, AY, AZ. And in third row we write BX, BY, BZ. Okay, this is all we have to remember. Now, how to find this given this? So it's very simple. Let's take I cap, then put your hands on this row and this column. What remains is this thing. So AYBZ minus BYAZ. Okay, multiplied by AYBZ minus BYAZ. Then minus J. Then hide row and column containing J. So row containing J and column containing J. Then we have these four elements. So it is AYBZ minus, AXBZ minus BXAZ. AXBZ minus BXAZ. And then plus K cap multiplied by, let's hide this. So we have AXBY multiplied by BXAY. Sorry, not multiplied, minus BXAY. Okay, so you can check for yourself that these are the components of A cross B. So this is how we find vector product of two vectors. Now what are the uses of vector product? So we have already seen a use of vector products, finding area of a parallelogram whose two sides or two adjacent sides are given by two vectors. Let's see another use. So use is checking whether two vectors are parallel. So if two vectors are parallel, then the angle between them will be 0. So A bar cross B bar, its magnitude is given by the magnitude of A into magnitude of B to sine of the angle between them. So if they are parallel, it is going to be sine of 0 and this is going to be 0. Okay, but wait, see, we have to find this. In order to check this, so it is quite tedious task. So we will not use this vector product to check whether two vectors are parallel or not. Okay, there is a simpler method. Let me tell you that. This is just one of the use, so I have mentioned it. So suppose two vectors are parallel or in same direction. So suppose this is A bar and this is B bar. I can draw this B bar here also. So this is my B bar. Now, if I multiply B bar with some constant, appropriate constant, I should be able to get A bar because they are in same direction. So I can say A bar equals to B bar multiplied by some constant. Let's call it K. And what does it mean? Is that AX into I cap plus AY into J cap plus AZ times K cap equals to this BX times I plus BY times J plus BZ times K into this K. And if you compare the components on both sides, you will get ax equals to bx times k, ay equals to by times k, az equals to bz times that k, and which means if you take ratio of ax to bx, it will be equal to ratio of ay to by, and it will be equal to ratio of az to bz, and that is some constant which we are calling k. Okay, so this is much simpler method to find whether two vectors are parallel or not. But we can use scalar product to check whether two vectors are perpendicular or not, because it's very simple to do so. So checking whether two vectors are perpendicular, so for that we will take scalar product a bar dot b bar, which is equal to a b into cosine of theta, and if two vectors are perpendicular, the angle between them will be 90 degrees, so it is ab into cosine of 90 degrees. Cosine of 90 is 0, so this is going to be 0, and finding this is simple because a bar dot b bar is just ax bx plus ay by plus az bz. So we have to check if we find this, if this is equal to or sum of these things turns out to be 0. If it's 0, the two vectors are perpendicular, and if it's not 0, they are not perpendicular. Okay, so to check two vectors whether two vectors are parallel, we'll do this thing. We'll find the ratio of components. If it is same, they are parallel. And to check whether two vectors are perpendicular, we'll find the scalar product. If scalar product is 0, two vectors are perpendicular. Okay, so we have seen a lot of things in this lecture. It's better to do some problems. So try some problems for yourself. In next lecture, we will see some problems on vectors, addition and multiplication. Thanks for watching the lecture.